Hey guys, welcome to the video for the foldable for level 2 triangle. If you are watching this video, you should have a paper that looks like what you see on the screen. On the other side, it looks like this. So it will be upside down on one side. We are going to start on this side. The directions say fold along the solid line, which is this. Cut along the dotted line, and then you will watch the video if you need the video to help you with finding domain and range. So I'm going to start by folding it. We have already learned about domain and range in cycle 3, that quiz you had about domain and range. But if you still need a little extra help, then that's what this foldable and this video are going to help you do. So if you fold along that dotted line, then it should look like this, and you should still be able to see Units 2, Cycle 1, Level 2 triangle notes. I'm going to unfold mine just to make it easier for cutting. Do not cut past the solid line. So, if you need help finding domain and range from a graph, you lift this flap. It tells you exactly how to do it. You follow the steps with the examples. If you need help finding domain and range from a verbal description, which is a word problem, then you follow the directions and you complete the problem. We're going to do these examples together really quick. So we're going to start with a graph. It says label the ordered pair or pairs on the graph. So that means we need to find the coordinates of each of the points on the graph. So I'm going to start with the graph on the left. From the origin, I am moving left 1, 2, 3, 4, 5, 6, and down 2. So left 6, down 2. That leaves me with an ordered pair of -6, -2. I'm going to zoom in on this. It's going to be blurry for a second, but it will clear up. There we go. So now I find the other ordered pair. From the origin, I move right 1, 2, 3, 4. And then I'm going to move up 1, 2, 3, 4, 5, 6. That is step 1. Label the ordered pairs on the graph. Step 2 says identify the domain, which is the x values. So when we have an ordered pair, our ordered pair is written x comma y. So if I am looking for the x values, then I'm going to focus on the first number in the ordered pair. So that means I am looking at -6 and 4 because those are the first numbers, and I'm looking for the x values. Put the smallest x value in the left blank. So if I have these two numbers, -6 is my smaller number. So that is what goes in the left blank. As I put that number there, and it's not in the directions, I look at the circle. That is an open circle, so this inequality stays the same. 4 is my larger x value. 4 has a closed circle, so I add equal to. And that is it for my domain. Now for the range, it's the same process, except I'm looking at the y values. So y is on the right, so I'm going to circle the two things that are on the right-hand side inside my ordered pairs. I'm going to put the smaller one, right? I have to determine which one is smaller. -2 is smaller than 6. -2 has an open circle, so this inequality stays the same. 6 is my larger y value. 6 has a closed circle, so I add equal to. That's it. That is the domain and range for that graph. Now, the next graph is going to look a little different because this time the second graph has an arrow. It's the same process. When you have an arrow, right is positive, left is negative. Up is positive, down is negative. When you have an arrow, one of your ordered pairs is going to have two infinity symbols, but it can be a combination of positive and negative. So first I'm going to find the ordered pair of my point. So from the origin, I move right 1, 2, 3, 4, 5, and down 2. So that is right 5 because it's positive 5, and negative 2 because I went down 2. Now, this arrow means this line is infinite. It keeps going. Well, it's moving to the left and up at the same time. It's going in this direction. So it's going to continue to move left but up at the same time as it extends. X axis runs sideways. So we move sideways first. Well, if I continue to move left, I am going towards negative infinity. So that is the first thing I put in my ordered pair. If I continue up on the y-axis, I am heading towards positive infinity. So my ordered pair for the arrow is negative infinity, comma, positive infinity. Well, now I'm going to do the same thing I did with my x and y values on the first graph here. X is the first thing in the ordered pairs. So I'm going to circle the first thing in the ordered pairs. The two things I'm looking at are negative infinity and positive 5. So negative infinity is smaller than positive 5. You can never equal infinity. So anytime you have an infinity symbol, it doesn't matter if it's positive or negative, you don't put the equal to because you can never reach or equal infinity. 5 has an open circle so that inequality stays the same. So then I move on to my y values, which is the range. Well, I have positive infinity and negative 2. A negative is always smaller than a positive, but the left blank doesn't have to be a negative. I could have two positives. I just have to make sure the smaller one is on the left. Negative 2 has an open circle, so this inequality stays the same. Infinity is my larger number because it's a number so big that we don't know it. So it's definitely bigger than negative 2, and I can never equal infinity, so that inequality is going to stay the same. So that's it for finding domain and range from a graph. Now, if we need a verbal description. So it says determine your independent domain and dependent range values. There's no trick for determining the independent versus dependent. That's just something you have to know how to do. So it says, Mrs. Flores purchased a bag of mini Twix bars to keep in her classroom. The bag contained 25 bars and each bar contains 50 calories. Find the domain and range of Mrs. Flores' eating habits. I like to eat Twix bars. So I need to determine whether the number of bars determine the calories or if the calories determine the bars. The dependent, which is the range, depends on the independent. Another way that you can think of it is the domain is the independent. That's what you have control over. I, Mrs. Flores, have control over how many Twix bars I eat. I can control how many Twix bars I eat. The number of Twix bars that I eat is the domain or the independent, which means the number of calories is the dependent, because the number of calories that I eat depends on how many Twix bars I eat. The more Twix bars I eat, the more calories I consume. Now, this is a continuous domain and range because I can eat part of a Twix bar. I don't have to eat the whole thing. It is continuous because you can eat part of a Twix bar. I'll probably end up eating the whole thing, but I could eat half of it. I don't have to eat the whole thing. So that's why it is continuous. So it has those inequality symbols. Now, domain is X and range is Y. Well, what is the least possible number of Twix bars that Miss Flores can eat? Well, 0. I could eat 0. But what is the maximum possible number? Well, it tells me the bag contains 25. So the most I can eat is 25. The smallest number goes on the left. The biggest number goes on the right. 0, 25. I can equal 0 if I don't eat any. And it can equal 25 if I eat them all. Now, the same thing goes for the calories. What is the least possible number of calories that I can consume? Well, if I don't eat any Twix bars, then I have eaten or consumed 0 calories. What is the maximum possible number of calories? Well, for this one, we have to do a little bit of math. So you need to determine what is the most number of Twix bars that I can eat. That's 25. And they tell me each bar contains 50 calories. So if I eat that whole bag and I consume 25 Twix bars that each have 50 calories, how many total calories did I consume? I'm going to give you a second and I'm going to let you plug that into your calculator so that you can do the math. Okay, so if you plugged it into your calculator and you did 25 times 50, that should give you a total of 1,250 calories. So those little Twix bars add up. The smallest number goes on the left. The biggest number goes on the right. It can equal 0 calories that I consume if I eat 0 Twix bars. But it can equal 1,250 calories if I consume all 25 of the Twix bars. So you need to determine your independent and dependent. Find the smallest possible number and the biggest possible number. It is similar to what you do on the graph. The smallest number always goes on the left. The biggest number always goes on the right. If you still have questions, please make sure you come to tutoring.